probably start about 2 minutes early. I'm going to give you a little bit of a warning. I originally designed this presentation because I was told I had an hour-and-a-half slot. So if you look at your schedule, you'll realize it's 75 minutes. So I'm going to try to motor pretty quickly through the intro. However, I am from the East Coast, which means it's in my nature to talk extraordinarily quickly. If I start speeding up too much and I'm just slurring my words, it's not from drinking. Just let me know, I'll slow down, and I'll keep on going. So today I'm going to be basically presenting the title talk, Lessons from the Trenches, Engineering Grade AJAX Experiences. The purpose of this talk, about 15 months ago, we started rethinking what it meant to build a rich interactive website for MSN and what's now Windows Live. So what I'm hoping to do over the next hour or so is walk you through a lot of the considerations and challenges we faced when we built our systems. So this talk is going to be fairly quite technical, but I'm not actually going to walk through a fair amount of code. The lessons and patterns I'm going to introduce are generally applicable to any way you build your rich interactive site. I'll illustrate how they tie back to Atlas, how they tie to Windows Live, but these could be universally applicable to anything you're doing on the web. So I'm just going to start jumping right in. Here's my agenda. The first part is I'm going to explain kind of how we rethought the web application model. And then I'm going to explain how we applied that to Windows Live. And that's the part I said I'm probably going to motor through so we could get to the real meat, which is what did we learn. I think that is the stuff that's most valuable. Furthermore, when I say what did we learn, I don't claim to have all the answers. I just have a lot of questions that we have addressed, how we've addressed them, and we're still learning from there. Figure out the clicker. Cool. So really quick poll. How many people here are developers? All right, cool. So I assume everyone knows what AJAX is? I could go quick through this? Great. I'll do it really quick just because I know if someone didn't know, they would never raise their hand. So what is AJAX? AJAX is basically a pattern where we could update the website without reloading the page. That's kind of the high-level way to look at it. So let's take a weather forecast. You enter 98052, hit Add. A little bit of JavaScript code runs. My beautiful graphical line there is the client-to-server designation. It goes to the server. Something happens. Returns some weather back to the JavaScript. And it runs, and the page updates. OK, as I said, I'm going to go quick through the beginning here. So the details. AJAX is just a development pattern. It's basically the idea that you make the request to the server, you process the results, and you update the page. The key distinction is that you're not round-tripping a whole new web page. You're updating basically segments of the page on demand. The technology for AJAX has been around for many years. It's just now coming into fruition because we're now focusing so heavily on experiences, mashups, and so on. When you look at the AJAX pattern, you'll discover it's very good for improving form interactions. For example, entering the stock, too much drinking a towel. Entering the stock quote and then updating the page, entering that weather zip code and updating the page. AJAX works wonderfully as a pattern for solving those simplistic form interactions. However, we found that as a pattern, it's insufficient by itself. So we use AJAX as one of the many tools for building our websites. So what is a mashup? How many people here know what a mashup is? All right, a mashup is basically a web application that consumes or remixes content and experience from different sources and aggregates them. What is all that stuff saying? Basically, I'll give some examples. If you were an Amazon affiliate and you integrated a hyperlink to Amazon, you basically created a mashup. That is in the most simplistic form. You consume Google AdSense, you're a mashup. You consume Virtual Earth Maps, you're a mashup. You expose services to other people, you're enabling mashups. So to me, this is actually a key value of where we're trying to go in the Web 2.0 space. So remixing the web. I'm going to use the term remix and mashup interchangeably throughout the talk. So what is the real web application revolution? Everyone jumps up and down and says AJAX is driving this revolution in how we build websites. Again, to me, AJAX was a development pattern. I want to step up and say conceptually what is really happening on the web. To me, what's happening on the web is the fact that we are now leveraging that long tail. We're leveraging the reach and breadth of what we could achieve by exposing our services. AJAX is the tool that's enabling that. Furthermore, it's more than AJAX. RSS is all about remixing the web, the fact that you're consuming disparate someone else's data into your site. RSS is being used for integration scenarios, and so on. So when I look at this, I say mashups is the real Web 2.0, is the philosophy behind it. We're going to create experiences and services that we're going to expose to the reach of the web. Our services then can be repurposed by someone else downstream and further consumed, and so on. Now, the idea of a mashup is more than just saying enabling yourself to be used by third parties. I actually view this as an entire conceptualization of how you would build your actual website. It's mashing up to me as an architectural pattern. If you wanted to build a mashup, or let's just think about it this way, if you were to build a modern application, what would you typically do? You would build components. You would make it reusable. You would eliminate the idea of trying to have no engineering in your web page with the ad hoc spaghetti code, and I'll explain what I mean by that, to enable this. This doesn't necessarily mean you have to be remixable downstream. And I'll just give a simple example. If you take mashup as a philosophy, and you started a website, didn't think anything about mashups. 2 months in, you built your website, you shipped it, and then your management shows up and says, we need to allow people to integrate with us. Well, if you took the mashup philosophy to heart and how you built your stuff from day one, you'll tell your managers, I'll do it, it'll be done in 3 weeks. You'll go on vacation 3 weeks because you already did it. You enabled it from the ground up. If you don't ingrain this in your philosophy, when the time comes where you decide that the wreath and breaches may be what you need, or that you want to reuse across your sites, it might be too late. So to me, mashup is not just the ability to remix with the rest of the web, it's the way we approach our applications. It's the way we build everything. It gives you the benefits. You can leverage your investments. I'm a big believer in stealing code. If someone in my team or anywhere in my division has built it, I do not want to build it again. And if you build your sites from the ground up to enable this, it'll be much more efficient. So I'm going to quickly flip over, but we've taken this entire philosophy to how we build all of Windows Live. So let me just fire up the right demo. So if I start with, it must be the other box. I knew I was going to confuse myself. There we go, Windows Live Mail. Windows Live Mail, as almost every Windows Live property, is a mashup. It's a question of, is it remixable by other properties outside of Windows? I'm sorry, outside of Live? Maybe, maybe not. We can make that decision later. But for now, I'm going to kind of illustrate what I mean. The folder list on the left side, the list of messages that are going to show up, all of these are built on the same shared component. It's a remixable list that we can then consume in subclass. If you walked away from the web, you would have built a list component that you would derive from and so on, as you would in a modern language. We're applying those same techniques to how we build our sites. Back to what I said about stealing or sharing, or depending on how you want to look at it, when I click on New, that rich text editor that we use is the same rich text editor we're going to use across all of Windows Live. We're going to build it once and then leverage it across the rest of our properties. Now, shifting gears to a more true mashup, let me get the right demo. Our Windows Live entry page. This portal page is actually what I would call the poster child for mashups. This illustrates what I consider the never-ending application. When does this application load? I can't tell you. The user's always changing it. They can add components, remove components, all on demand. And we do this all on the client. So if I go over here, expand down, let's just grab a quoted a day, drag and drop it. We don't round trip to the server. The application just loaded the component in place, instantiated it. To enable this, it requires a bunch of interesting challenges, which is what I'll address later when I get to the meat of the presentation. So why this mashup philosophy? I've addressed some of these already. First, sharing resources. If you can build components and reuse them, obviously you could get more leverage. I argue when you do that, things become more robust. What is better, the one-office solution or reuse one that's already been in production? The one in production, the more it's going to get used, the more code coverage it's going to get, the more stable it's going to be. This third point, it's one little point, but it's a very powerful message, and I'll give the scenario. Today, I want to integrate with another property on Windows Live. Well, it's not today. Historically, I want to integrate with someone else in MSN. My program managers and engineers will sit down with that team. They would negotiate and say, we want to do this. And they'll say, well, we can't do that. They'll butt heads for a few weeks, come to agreement with an engineering plan. A few weeks later, they'll implement that engineering plan. Then they'll go through a few more weeks of testing, and maybe 6 months down the road, it ships too late. So with the idea of taking mashup philosophy to heart, I now, in Windows Live, call up the guys in Hotmail and go, I really want to get an inbox on my page. Well, guess what? They've already built themselves to be integrated. They have services I could consume. So their question's first going to be, do you have a business justification? Please always answer that one. And assuming the answer is yes, the next one's going to be, what's the scale requirements? Again, make sure you're not going to fall over when you integrate. Assuming the answers are yes and yes, they just hand me the interfaces to their system, or maybe even a package with an experience. I drop it on my site, 2 weeks, we're live. So this is really why Windows Live is heading down this direction from our perspective is, not only is it making our development more efficient, it's allowing us to be much more agile in our processes. We can provide a consistent experience. This actually becomes a challenge when you remix outside the scope of your domain, outside the scope of your organization. I want my site to be pink polka dots, and I go integrate some component from a third party. Is it going to be pink polka dots? Well, it depends if it was designed with the right patterns and approaches. We can scale better. I'll address that one later, but the idea here is that we could not only are we leveraging our investments, but we could leverage our ability to cache the code that makes up that description across the network. So a simple example. Underneath Windows Live is a framework script. While we don't do it perfect today, our goal is every property is going to share the same reference to that script. You visit any one of our properties we loaded, it's cached. As you visit subsequent properties, everything we load is merely incremental. So we could do a lot more on the client and handle the fact that we have a lot of code to deploy. And the most important reason to do all this, and this better be the driving reason behind any technological decision, is that you believe you're delivering more value to your customer. And then the key thing for us is, in Windows Live, we decided from day one, whatever we do is going to be done one way. We did not build an internal mechanism for us to build our sites and then go to the developer community and say, here's how you shall extend us. It's different. No, the way you extend Windows Live is the same way we build our properties. That actually yields everything I said up there. We know we're going to be more robust. We know we're going to be more stable because we're running on the same practices we're asking the third-party community to work on. So the gadget ecosystem. How many people here know what gadgets are? Sanaz, I'll just give a quick lead into, go to Sanaz's talk at 3 p.m. if you want to learn more. eBay is talking, I believe, at 1 p.m. and presenting their gadget and how they integrate with Live.com. I highly recommend those to get the real meat and how to build one. But as I said, at the core, in all of Windows Live, every UI component we build is a gadget. As I said before, we build the same way, so third parties extend Windows via that. But think about this. When I started, I said, Windows Live is going to build on one pattern for everything we do. So look at the opportunities this is going to enable us. I'm going to be able to extend gadgets into other properties, such as spaces. It's right now a matter mostly of scheduling. Technically, we could do it because we're all built the same way. If we build another property and we want gadgets on that property, we will be able to integrate it. We're going to work on allowing you to host gadgets on other sites. Now, the other day, the Atlas guys demonstrated a gadget on your site. That's the first step. The next step is in Windows Live, we have a lower level way to program gadgets, which integrates more tightly in our system. We're going to even enable those to be on third-party sites. So you can see where we are going. Extend Windows with gadgets on the sidebar. You've all seen all the sidebar demos in the keynotes. Again, we're extending this whole philosophy out across the entire ecosystem. So now is where I'm going to start digging into the real meat of the presentation. What did we learn? We learned a lot about building applications. First, we recognized, and these are what I'll spend the rest of the talk going through, but how to handle the real-world issues beyond just the AJAX pattern. We had that desire that we needed one platform, and I think I've illustrated some of the benefits of that. And we created patterns and approaches to work around the limitations of the browser. Now, I want to just give a little historical perspective of the environment we're all programming in. And back in '95, I was on the AJAX team at that time. We didn't know if we were going to be IE4 or IE5. And we were working on DHTML. I wrote the initial spec for DHTML back in about '95, and the intent was to leverage that really dynamic interactive layout engine known as HTML and provide you the ability to build something interactive on top of it. If you step back for a minute and think about it, DHTML is essentially a very rich dynamic forms package. It does not have all the things you need to build a very rich application inherently in the system itself. That is the reason why you're starting to see we have these Atlas toolkits. We're building these frameworks. We're trying to layer in and simplify the needs of the development community so they could build applications in this environment that is really a little bit immature at this point. Now, that's not a bad thing because we're getting a lot of shared knowledge, not in Windows Live, but the IE team. I'm sure the Firefox guys. We're seeing how the web is evolving, so hopefully, as the platform continues to grow, things will be done right. And the key thing here is we're still learning. It's amazing what we see people do out there, and every time they do it, it's more knowledge. Every time we see a performance issue, it's something we have to address and learn from. So now looking at AJAX, and this is my favorite one because this happens a lot I see in the world. Everyone jumps up and down that AJAX is this magic fairy dust that you can sprinkle on your site and it solves all the world problems of your website. Actually, it is very powerful to solving lots of problems. But by itself, it does not necessarily mean your application will scale better, run faster, and amazingly enough, it may not even offer a better experience. And I'll illustrate in one place in Windows Live where we used AJAX in a way that actually hurt the experience. And we know we're going to fix it. That's why I'll show it to you. But the key point is a lot of times your applications may scale worse with AJAX. And I'll explain why and what we are doing, and even how ASP.Atlas has addressed a little of this. Your application may or may not run faster. We're starting to learn in Windows Live that as we really push this, where we think the application was going to get faster, in some cases it was getting slower, and we have to adapt our requirements and so on. So evolving this pattern. So this is kind of my intro slide to what I'm going to cover for the rest of the talk. Basically, we have an architecture that enables client-side page composition. Don't worry, I'll explain this as I go on. Modern development patterns. How do you componentize, build your components? Those next 3 points, network management, resource, and proxying, kind of go hand in hand. How do you handle the fact you're on a constrained pipe that's not only constrained in bandwidth, but unreliable? How do you do theming consistency? And last but not least, a favorite, what do you do about that cross-browser? While the browsers are ubiquitous typically in their technology, there's not much we could, I mean, there are always going to be little differences in rendering and APIs and so on that we need to address as we build our stuff. So I'm hopefully going to help you answer the question, what does it take to build a robust, rich application? Or at least help you understand the considerations you need to know. So let me start with the application container. I basically divide the way the browser works into 2 categories, these mashup philosophies. A server composited page and a client composited page. Now, these are not mutually exclusive, but let me just explain what they are completely orthogonally. First, server composes pages. That's the traditional web. You visit a web page, the server's processing and spews out a long stream of HTML that gets rendered on the client. That's a server-composed page. The client is just interpreting what was sent to it. A client-composed page, on the other hand, is typically a shell of a page gets sent down, a template. And then the client manages all the resources and controls and handles the embedding and rendering of the rendering. So rather than me walk through those points, I think it's best illustrated by a demo. The one thing I want to say when I make the demo, neither one of these approaches is perfect. It's the scenario that drives it. So you should make the decision which one you use based on your scenario. So I'm going to start with the Google homepage. The Google homepage, while it uses AJAX, and this is why I'm explaining it's not mutually exclusive, is actually a server-composed page. And I'll show you what I mean. Whoops. If I view source, I'm going to search for one of the stock quotes, Dell. There it is. I'm going to search for, so you'll know, I'm just going to use that to illustrate that Dell was already in the web page when it loaded. If I edit this list, and let me add IBM to it, right now this is all client-side, but the moment I hit the add button and save, the page reloaded from the server. To show you, I'll search IBM. You'll see the string IBM is now in the source. Now, a client-composed model, if I show you what we did in Windows Live, this took it, we went to completely the opposite extreme. In Windows Live, everything is client-composed. So if I show you the source of Windows Live, it's basically 3 screenfuls. And actually, I wanted just to show you really quick, just to show you what, because I'll emphasize this later. There's lots of screenfuls being downloaded for the Google homepage. As I said, it's just, that's only to indicate the fact that how it's getting rendered. If I start adding quotes to the stock quote over here, actually let's just start by doing the same thing I did before. Let me search for Dell. Dell is not listed in the stock foot module here. If I add another one, IBM, it got added, the page didn't reload, it was all client side. Not only did we do this philosophy for what I would call the simple AJAX operations, every one of those components on the page was pulled in to the client via was interpreted by the client. What we've done in Windows Live is we send down basically the semantic structure of the page. We send down the initial settings of the page to tell us the initial components that we need. Then the client goes back to the server and says, oh, I want a stock quote, I want horoscopes, I want quoted a day, I want weather forecasts. If I add a new component, it gets requested on demand and added. If that component has resources, such as scripts and style sheets, they would be pulled in on demand. We don't have to reload the page, hit the server, and so on. Now, in reality, we're learning that the best result is probably going to be a hybrid model. We're going to want to serve some stuff initially with the page to save that extra connection, to go get the metadata about the page. But once that page is up and running, we're predominantly trying to focus on the client side. The other advantages, which I'll illustrate later, when we go with a client-composed page, we can now stage our pages. Now, as you build more and more interactive functionality in your site, it takes more code. And I'll give this scenario here. A help button. Let's say you built a really rich AJAX help. And you integrate that in your page the traditional way of having the server generate the help button and include a bunch of scripts. Well, if you go do a performance analysis, you might find out that that help button is stalling your page for 3 seconds before anything can be done because it has to pull in all those scripts. We could stage the page and say, you know what, the user's not going to click help until the page is loaded, until there's something to look at. So we could actually load what is necessary for the page and then choose to load help and other functionality later or potentially even on demand. So client composition. To illustrate this, I showed you on the Windows Live, this is an old rendering of Windows Live before the update 2 weeks ago, but this header in the search box is basically a gadget. We will be able to drop the same header on all our properties, and we're going to be doing that soon. The folder list loads, that's a gadget. Now at this point, if you watch, things were loading in different order. Well, this is what I call about prioritization and staging the page. We could decide if we wanted to that what's more important, getting the RSS feeds or getting the Hotmail inbox or the ticking clock. In reality, the ticking clock was probably the least important, so it was the last one we loaded. So now drilling a little more deeper and getting a little more technical, the modern development patterns. If you want to start building a remixable experience, you need to have basically modern facilities available to you in the language. You've probably seen this type of pattern already in the Atlas presentations, but we've basically established the ability for you to create namespaces. Why are they necessary? Well, think about the remixable, mashable world. You build a component, and you decide to make a function called check this, something generic. You drop it on someone else's site. They created a function with the same name. I'm sorry, you just broke. I highly doubt both of you implemented that generic function the same way. So what's essential, the first thing, again, if it was a modern language, you would have this, is namespaces. In Windows Live, we have every individual property namespace based on our property name. We have our shared infrastructure namespace separately. In this case, I chose something that might not be globally unique, but is pretty unique, my name for my namespace. So for Scott Isaacs, and then I've initialized and disposed. This is the other half of having a modern system. Remember I said in the beginning, DHTML was a modern forms package. So the interesting challenge is as being a page model, the life cycle was typically defined by the page. So everything gets created, allocated, and built up until the user leaves the page. That's well and good if you have a scoped application. If your application just has, let's say, a map and 2 other components, and that's all that you're going to run, that life cycle might work okay. Take something like the live.com portal, the live.com homepage. You're creating components and destroying components on demand. Well, if I'm doing that and I'm not allocating and deallocating those components in real time, my page is going to go bigger and bigger and bigger and bigger and bigger until they leave. Not a very good model, especially if the guy is indecisive and keeps adding and removing that stock thing 80 times. We got to have discrete life cycles of our components. So we have an initialize and dispose that we could call. The other half is separating semantics, presentation, and behavior. And then earlier I made that statement about ad hoc spaghetti HTML. A traditional web page, we all fall into this rut as a web developer. There's some stock thing rendered on the screen. and I'm just picking out a scenario, but you could apply this to almost anything on the screen. You want to go get the quotes and the list of companies that were in that stock quote. I know what I do when I'm lazy. I go document element by ID, go get the stock table, grab the first column, I got my stock company list, grab the second column, got the quotes. But in the remixable world, you might not be responsible for that component. And actually, in reality, if you're not the stock object, you should not be interrogating that way for a simple reason. Me, the guy that was in charge of that stock component, said, I want percent change as the second column. Now all your math went crazy and you're pulling the wrong values and things start breaking. Well, if you were building in a real modern language, you would have done this. You would have built an object that represented the stock. It would have had an interface. Maybe I'll just simplify, say get stocks, get stock quotes. And the presentation that was on the screen would have been private to the implementation of the object. We're applying that same philosophy for how we build all our components. So that allows us to adapt the actual presentation without worrying about breaking the consumers of us in the remixable experience. So as you start looking at this, you go, well, by itself, that doesn't really address all the problems. Integrating components without collisions, we kind of covered that with namespaces. Consistent theming across components. I'll illustrate that when I get to my build slide on how gadgets work. I'll address the behaviors HTML structure. How do I take that weather component and associate it with something on my page? Or a better example is, when you saw that rich text editor in Hotmail earlier, the way that worked, we merely dropped one little artifact on our web page and said, any text area we find on the page, turn it into a rich text editor. The text editor, we didn't have to write any glue code. We didn't have to write up a lot of funky code that says, go find this element, tie it to this thing. No, we have an infrastructure that does that binding automatically. Asynchronous client-side page composition and deployment. I'll address that, all those points and details as we go through. So what are the patterns that we looked at? First, encapsulation, we covered that, and so on. But the advanced requirements, asynchronous deployment. How do you manage that network so I could say get code, get code, get code, combine it, instantiate object? As I explain later, there's some real performance challenges in the way the browser deploys scripts to the page. And we've worked on addressing that so we could get parallelization of code deployment. What are the patterns for asynchronous component communication? I'll give you a simple challenge. Let's look at the live.com page for a minute where you have a bunch of RSS feeds. I want to build a new component that can consume any RSS feed that shows up on the live.com page. Now, the live.com page is dynamic. People can add a feed, remove a feed, add a feed, remove a feed. So our entire communication model between components, in Windows Live, we don't have the traditional controls collection where you say, because we don't know the controls that may exist on the page. Instead, it's more of a register, a publish and subscribe thing. We say, I want to subscribe to anything out there that has the RSS interface. And anytime one of those objects come available, I get notified. If one gets destroyed, I get notified. So it allows me to build these very, very dynamic systems. Patterns of scope CSS layout. The challenge here, how do you build a remixable component that has a style sheet where your style sheet won't mess with the rest of the page and the rest of the page won't screw up your component? And in the same way, how do you get the pink polka dot or whatever color they want in your component? And the last one is process isolation. That's a biggie, so I'll leave that to later when I talk about security. So let's look at what a gadget is. And what am I saying, what have I been saying for the last 25 minutes about how do you separate this? Well, first thing we might do is, in this case, we made a decision. We're going to put a weather component in that div. So, and in this case, it's a purely client composite component, so there's no content in that div at this point. We just have div class equals weather. We would have dropped an artifact on our page. I'll just explain it since I didn't have room on the slide. In our model, we go web:/binding. It's an XML tag. Anything with the CSS selector .weather is going to download two files. The script that makes up the weather.js, the weather CSS, when they're available, is going to attach everything with that class weather to that object and fire it up. So to summarize what I just said, anything with class weather is going to get bound to the function live.weather. So now we got we're now in objects instantiated. That weather component would have done that AJAX request I showed you in the first slide, go get the weather data, at which point it's going to come back and render on the screen. Now, remember before I made that statement about, well, got to be careful. You don't want your component to be screwed with by the rest of the page and vice versa. If you've been looking closely, you might notice something about that CSS sheet. What's the class name of my gadget? Live.weather. What's the class name I applied in my CSS sheet? .live underscore weather. Now, we had to convert the dot to underscore, otherwise it would have been a compound CSS selector. It wouldn't have applied correctly. So when we bound that gadget to the class weather, that div actually became div class equals weather space live underscore weather. Now when we define our style sheets for our components, we can scope them to ourselves. No one else on the page should have live underscore weather, because if I did my namespace incorrectly, I've made the proper encapsulation. So this allows me to protect myself and isolate myself from the rest of the page. Oops. Live clipboard. How many people have heard of Ray Ozzy's simple idea, the live clipboard? Okay, I highly, highly recommend a talk tomorrow, assuming you could wake up in time at 8:30 a.m. It has not the best name, Wiring the Web, but it's I think it's a very powerful talk on where a lot of this Web 2.0 stuff and where we are going. When I look at Web 2.0 and I say mashups are really the philosophy driving it, what are the constituents? What are the attributes of a mashup? Well, first, let's start with, you have RSS. I think that's an integral component of Web 2.0. You have these web services. You have the ability to remix experiences. There's another concept. How many people have heard of microformats? Tantec, are you here? Yeah. Mr. Tantec Selik over there, he's with Technorati. He had this concept called microformats. I think microformats are another key attribute of this whole Web 2.0 sphere. Microformats are the idea that you can put semantic definitions on your HTML simply by associating classes with elements. So if you have a contact card and you say, give that thing a class of vCard, you can then establish what inside that vCard element is the name, the address, and so on. There's one for calendar. The nice thing is it's a loose system. You can invent microformats. But what microformats can be used for is another mechanism to remix and integrate with the web. What the live clipboard is, and this was Ray's simple idea, was how do we take these microformats and leverage them in a way so they could serve as a mechanism for integrating your semantic data with the rest of the web. And rather than continue rambling, let me just go right to the demo. Which machine did I put that on? There we go. We're done with that. First I'm going to start with, and the other point about this demo is this demo is going to also illustrate how we are trying to bind to existing content on the page and how we could derive behavior, and I'll explain that in a moment. Let me just start with the microformat. And I'll warn everyone, there is an XHTML error in my code here. Even though the browser is forgiving, all my attributes should be quoted. So if you're really technical, don't beat me up. We know about that. I just didn't have a chance to go replace them. But where you see div class equals vCard, I've created a microform. I basically said this is a microformat representing a user's contact. So then I have class equals email. There's the email, tel, ADR. Those all are providing semantic meaning to that generic content. As I scroll down this page, in this page is very simplistic, but I dropped a bunch of basically microformats on the page. By themselves, they're living as an island. But remember I said I think this is a key part of the ecosystem for remixing the web. So what we've done, and this is where I'll kind of show how our binding system works. I could basically say anything on my page that is a vCard. So this is a CSS selector. I assume if you're familiar with CSS, you'll recognize this. This type is the JavaScript class that I want to instantiate. And basically, every vCard element I find on the page, I'm going to bind one of those live clipboard container objects to it. Then I'm going to basically specify the resources that make up the clipboard container object. I need two resources. I need clipboard.js and I need clipboard CSS, clip control CSS. I'm sorry, clip control.js and clip control CSS. I'm going to do the similar definition for vCalendar. In this case, and I'll explain what this is, I said I don't want to support pasting into these, and so on. So now going back, when the page initially rendered, I don't know, it might happen too quickly. I should have throttled this page. If you look really quickly, you'll notice that those translucent clipboard image wasn't there. The page just rendered. What happened was we dynamically deployed the functionality to say, any microformat on the page, I want to make copyable. So you're thinking, well, why would you want to copy this? Well, this is getting back to the value. So let me go copy I'll copy the H calendar. This is an event. Now, in reality, I wanted to keep this demo simple. First thing I want you to notice, I went over to Firefox. So this shows you how interoperable the whole system is. I copied it from IE. I'm now in Firefox. I'm going to paste, and I dropped the calendar into this other page. Now, on the event item. Now, this consumer could have been an eventful calendar. It could have been my shared calendar in Hotmail. I could copy and paste these, or I could have used maybe a great thing for Eventful. If you know what that is, it's a site that would help you with events. Them providing this format would now allow you to transport these events from one site to another to another. I could do the same thing with other microformats on the page. Again, I'll go over here. I paste it. Now imagine I pasted that into my contacts. This person now quickly got added to my contacts. It becomes a great way to integrate little pieces of data, microformats from your web page with the rest of the web. Now, the other thing I want to make a point is what you're seeing here. We've been saying that we're working on adding microformats across Windows Live. Well, the way we're engineering it is, all we're going to need to do in Windows Live is add the semantic markup. So all we need to do is make sure all the contacts in Hotmail are going to be adorned appropriately with the right semantics of a vCard or an HCal or the vCalendar, say they're a calendar event. We're going to just drop this binding behavior in, and they will automatically become remixable into the rest of the web. We're also going to take the same functionality and bake it in so if you start building gadgets that have microformats, we'll be able to automatically apply and turn them into a remixable component. So inside your gadget, you could have your contact information that would be a microformat that you'll be able to copy out and drop into another, into a consumer. So my key message here is, one, go to the talk tomorrow, but two, really start exploring adding microformats to your web page. Even if you're not surfacing them, we need to start establishing that ecosystem of relevant data. So continuing on. Now I'm going to get into the meat of how we evolved the AJAX pattern. And I'm going to walk through a bunch of network scenarios. First, XML proxying and scalability. Well, here's an interesting challenge. Real simple. You want to build a mashup. You want to consume an RSS feed. Is it easy? Oh, it may be, depending on your point of view. But the interesting challenge is you can't just go fetch that thing in the browser. You don't have access outside of your domain. You need to build a proxy on your server to enable you to get at that data. The ASP.NET Atlas technology has this bridge technology, which basically makes all of this very transparent to you, which is very good. But there's also some considerations you need to take into account. If you are proxying through your server, you are now paying the bandwidth for everything you want to integrate with. Your scalability is now tied to the ability to hit your server, to jump, to come back to your server, and to jump to the client. In Windows Live, where we consume RSS feeds, we in some ways maybe improve scalability for the RSS providers. We have 1 million people, let's say, consuming the Slashdot feed. We'll hit Slashdot once, cache it on our server for a short period, and then be able to distribute that to all our users. But we've made the decision on our end that we're willing to bear the cost of that proxy. Now, people typically go, well, why don't we just fix this XML HTTP object? Why can't it go cross-domain? If anyone has followed my blog, I actually for a while would bitch about it, frequently saying we should just open it up. The reality is it's not that simple. And I'll explain why we have this XML protection in place. It's very hard in the browser to distinguish between an internet request and an intranet request. If XML HTTP was turned on universally, any web page that loads, if they knew the URL inside your intranet to an XML file, they would have access to it. So everything in the intranet, maybe you could claim is public. You clearly don't want your intranet to be accessible. So that is the reason we have that sandboxing around the XML HTTP object. There are creative solutions that you're starting to see appear. One of the interesting things is scripts can be loaded from any domain. So people are finding out that they can load data from other domains via scripts. You need to be very careful with that approach, because if you load a script, that script is executing. So if you're getting a service from Joe Nice Guy, who becomes Joe Evil tomorrow, and he starts serving code into your page that is interrogating and pulling all your privacy data and sending it back, you have to be very careful with that approach. If you're going this way, you basically need to use just JSON, and you need to parse it. How many people here know what JSON is? And I'm not referring to if you have a son named Jason. JSON is JavaScript serialized object notation. Simply put, It's the literal notation of what a JavaScript object looks like, so you could quickly evaluate it and construct a JavaScript object. The interesting thing there is that since it's being evaluated, it's being executed. There's a parser. I don't know if he's in this room. There's a guy, Douglas Crawford, who runs the site, jason.org, json.org. He has a great parser that will make sure your JSON strings are quote-unquote safe. They're not trying to run arbitrary code. And often when I start going down this path, people are like, what about maps? Maps seem to be loading stuff. I didn't do anything on my server. I just dropped the map in, and they're running great. Well, maps are unique. They are actually missing the X in AJAX. They don't really use XML, most of them. Instead, the images in a map are algorithmically determined from the latitude and longitude provided. As you're dragging the map, they're just loading new images. So while in philosophy it's an AJAX component, in reality it's not using XML. This is one of the reasons, ignoring if there's a business justification to surface it, you don't find geolocation services built into maps, because it would require a cross-domain request to go make that type of query, unless they use one of those creative JSON type script approaches. Web service integration. This is another thing that ASP.NET Atlas does this naturally. We do this in Windows Live. We built ourselves basically to the same approach, which is we do not want to continually parse XML. When we hit our web service, we don't want to crack open the XML envelopes. If you're familiar with SOAP, we don't want to deal with the SOAP envelopes on the client. It's expensive. It's slow. We've got to fire up more objects. We've got to parse the things. So instead, we built basically JavaScript proxies. So if I call Hotmail, I go hotmail.send, and the client, I could just call sendmail, pass in the arguments for sendmail, provide a callback. It's a JavaScript structure. It goes over the wires JavaScript. The server demarshals it to a CLR, in our case, a native CLR object. It gets processed on the server. It gets returned as a CLR object, marshaled on the server to a JSON object, sent to the client where we eval it. What all that basically says is the client deals with JavaScript. It doesn't have to deal with anything else. When it makes a call, it hands out JavaScript. When the call comes back, the structure returned is JavaScript. It's a natural approach. What's interesting is I'm starting to find out that this approach may even be good for things that are structurally rich. For example, and we don't do this yet today, but it was something I discovered. RSS feeds. Our live.com RSS proxy normalizes Atom and everything else to a standard XML RSS feed. We send that XML to the client and we parse it. Well, I discovered that parsing a 155K file on my fast dev box took about 400 milliseconds. Now, 400 milliseconds doesn't sound like a big deal, assuming that I was able to spin off another thread. Unfortunately, the browser's single-threaded. That 400 milliseconds is on the threshold of the user recognizing their browser locked up. Furthermore, combine that with the fact that that's just the parsing, not the actual manipulation of the object. I'm even slower. For fun, I normalized on my server RSS feeds to a JSON format, sent it down as a nice JSON string, evaled it on the client, just executed it into a JavaScript structure, 15 milliseconds. Now that, and you know what? Anything in 15 milliseconds or less, I argue is really immeasurable because the browser clock isn't that accurate. So I was basically in the noise. That was a good thing. So basically, I try to tell most people, if you're dealing with the web world, figure out how to efficiently model yourself for the browser. Use XML if you're consuming a third-party arbitrary thing, is XML great. If not, explore other approaches such as JSON if you really want to gain the most efficiency. Optimizing the network. This is back to my statement in the beginning that basically AJAX does not necessarily make you more scalable and more efficient. And I'll give you an example. We're starting to actually see some of this on live.com where we're going to have to readdress some of this. Imagine you have a stock quote on your page, weather component, top articles, horoscope, and all those are requesting their data individually. Well, start adding up those requests. This first time I load the page, ping for stock quotes, ping for weather, ping for articles, ping for the 10 feeds. I'm making all these requests one after another after another. Now, a server render page, I would hit the server once, it would have served it. So what we need to start exploring is, one, caching opportunities. If your data can survive even 5 minutes of being cached, you'll gain great efficiencies. So if the guy leaves your page and come back, maybe you don't have to hit the server right away. Maybe you'll do it a little later if they're sitting on a page a while. The other thing, look for opportunities to batch requests, especially what I say, anything that requires upfront processing that might be going to the same data bank. You don't want to have to re-authenticate your user on every little request. I believe Atlas yesterday was announcing they have a batching technology built in to enable this. Am I seeing a shaking yes? Good. This is something that you'll naturally get in ASP.NET Atlas to help you be more efficient with your AJAX, with your Atlas applications. Be wary of security. I could probably spend an hour on just this one slide, and I'll try not to. But let's think of the historical traditional web. I'm going to use Hotmail pre the new beta, the old way Hotmail worked. Hotmail would go to the server. It would go in the back and behind a firewall, query its database, get your inbox, get your list of folders, compile them into a web page, server compose page, send it to the client. What were the attack vectors? Well, what were the attack vectors from the client? Well, screen scraping, getting bad code on the machine. Truthfully, you can't do much about that. But from a perspective of how you engineer your app. What becomes interesting, though, is as you start exposing your data out, via AJAX-type interfaces, you're exposing yourself to much greater risk. How many people here know what XSS is? All right, how many people have heard of cross-site scripting vulnerabilities? All right, XSS was the acronym. Cross-site scripting vulnerabilities are basically where, via URL, someone sends some data in a query string to your server that you didn't properly validate that got sent back to the client. Now, what can happen? I could maybe send code into your web page and start running in the context of your web page. Well, XSS is just one of those challenges we all need to address. It's an industry challenge that we all need to address in all our sites. Well, as you start exposing services at the edge, XSS becomes much more of a challenge because now you have all these entry points that people could hit you with. The other point of security is what I call the unintentional security. Now, I'm going to use Gmail as my example here. I do not know Google's intent when they released their interfaces, but what intrigued me right when Gmail was announced, within 3 days, hackers have figured out, if you call them hackers, people figure out how to leverage the Gmail storage as a file locker. Well, why did that happen? They exposed services so they could build their website. They may not even have considered, and I don't know, but they may not have considered the remixable aspects of it. So the moment you're exposing interfaces, you got to think, one, I don't really want, even if you don't want people to use them, they will. So be ready for that. The flip side is what I call the unintentional DOS attack. You did expose yourself to be remixed, or whether you did or didn't is almost irrelevant, and the guy was hacking on you, and in a tight loop, he starts pounding your system. It's much more likely now that you're exposing services in the traditional web, which was loading a web page. Unintended repurposing address. The other thing is the other half of mashups. Today, and hell, I keep using Google as my example. I'll keep going. It's fine. AdSense. When you drop AdSense on your page, you drop a script. And it's served from Google's server. Actually, I won't even use AdSense. Let's generalize this. Almost all ad technologies delivered via including a script on your page. Well, what's interesting about that is the moment you did that, you assumed the trust. You implied a very high level of trust with that partner. Because you basically gave that partner access to everything in your site. You better feel comfortable that that partner is secure on his end, that his scripts cannot be manipulated in bad ways or his server compromised, because then they could be serving bad stuff to you. Now, the point of me bringing this up is I want you to be aware of these things. It's one of those, you make the decision, is it acceptable risk? In most cases, it actually is, as you're dealing with partners. But be careful if you're a major organization consuming Joe Hobbyist script into your site. You really want to think through that before you go ahead and do it. Advanced network patterns. While AJAX is a simple request response, it really does not prescribe how you can efficiently manage the network. Before AJAX, and this is just a traditional web model. Well, you visit a web page. You're browsing for you look at the web page, you leave the web page. Whatever that web page was doing was quickly severed, forgotten about, and a new page loads. That was the pre-AJAX model. Requests were all typically equal. It didn't matter the order things really loaded in because it was just one rendering. It was one instantiation of the page. And usually there was a limited amount of script. As you start building richer and richer sites, you must be more aware of the unreliable network. And my simple example here is, I'll illustrate it again later, shopping carts in the pre-AJAX world. The guy hits the buy order button on your shopping cart. It fails. Okay, not the best experience. The user saw a 404 error. We all have learned what to do when we see 404s, refresh. Not the best model, but it's been taught to us. With AJAX, what do you do when things fail? There's no navigation. You need to bake it in your system. Some requests are relevant to context. I'm going to leave that one to the next slide when I get there. Some requests are more important than others. You preload 100 images. The guy hits buy it. What do you want to do? Get the images or make that order? I would hope you want to get that order out. And potentially have a lot more scripts. So the big thing when you look at when I look at advanced networking patterns is how do I mitigate the fact that I have very limited bandwidth, I'm on an unreliable system, and I want to get my application running as fast as possible. So first, let's look at the constraints that we must live by. One, there's no reliable transport. I can't fix this for you. You just got to know that that's the way the system works and plan to react, or to plan not to react. That's the other key thing I want to make throughout this talk. While I have lots of suggestions, it's more the decision process of whether you act on them depends on your needs. If you just recognize that all these exist and decide to do nothing, it's better than just ignoring them. Browser uses at most 2 simultaneous connections per domain. What does that mean? What that says is when you request 50 images, let's say, for your web page, only 2 requests are going to occur at a time, back to that one domain. There's ways you could optimize for this. Browser offers no built-in facility to interact with the network stack. When you make a request, you don't know when it's going to happen or how it's happening. It goes out, and hopefully at some point you get called back. So let's start with the unreliable network. Maybe this is good, maybe this is bad, but with AJAX, almost every AJAX app is assuming success. You can make the decision that's what you want to do, but I'd be very careful, and using that ordering scenario. You go build an AJAX shopping cart, and you think it looks so cool, and it runs great, and it seems to be a better experience, and your orders drop by 20%. You may not have realized that maybe your order system was never reliable, but in the historical web model, the 404 error people were getting, they were refreshing, and the order was still going through. Now with the AJAX model, since maybe you had made the mistake and assumed success, all your orders are getting lost, and the user doesn't realize they never got placed. So one of the big things you need to do is make sure you provide proper feedback. The other challenge with the AJAX is if the user makes a very quick request, and that's the illustration up here, they sit by it and very quickly close the browser. Did the request get there? I don't know the answer. Some browsers sever right away. Other ones, the request may have made it, but that's one of the challenges. So one of the key things here is since we can't control the unreliable network is proper feedback. Let the user know there's something in process. Hotmail lets you know when it's working. In IE, this is just a little programming trick. IE has an event called onBeforeUnload. If you send out an order and didn't get a response back or something that requires transactional integrity, you want it to happen, you could explain to the user that you didn't get a call back. You don't know yet if the actual thing happened. So you could ask the user. The key point is ask to have them stay on the page. The user could just say, screw it, I don't care if the order went through, and they could leave. But at least you have the opportunity to hold them there. Emulating the web model. Now, before I said pre-AJAX, you visit a web page, it loads. While it's loading, you leave the web page. You don't have to worry about that remember that 2 connection limit? You don't have to worry about it. All the connections got freed. Now, in a really, really rich AJAX app, and I'm going to use Hotmail as my example, we have contacts and the inbox inside the same page. They're sharing the same set of network connections. Now, imagine Hotmail was preloading 2 very large attachments from the server for an email. And the guy hit calendar or hits contacts. Well, guess what? Nothing's happening because the 2 connections got clogged by the 2 attachments from my previous view. That's really not what you want, but it's one of those things that's going to pop up as you build these richer applications. Instead, what we've baked into our network stack is we built a stack that manages all our connections. We don't send connections out to the network. We always control the 2 connections we actually put on the network, and the rest we maintain in our own stacks. So if someone switches views, we can say, release any request from the previous view, just like the web would have done when I switched pages, and start using those connections for the new view. Now, the demonstration is more visual because, unfortunately, without loading up a network monitoring tool, which I don't have with me, it's more just to give you an idea. If I'm loading this, and imagine this email, and again, I'm going to just have you imagine, had 2 very large images, and they were just loading. When I hit contacts, we could do this instantaneous because this would have been stalled if 2 large images were coming in. But Hotmail was smart enough to say, switching views, everything associated with inbox, free those connections. I don't need them anymore. The user's not in that context. Let me now free those up to use in the new context. prioritizing network requests. I've kind of hit upon this through the whole thing, and this is going to be the lead-in for my next slide. You're preloading up 50 images, a guy hits buy it. Well, we've decided that, well, due to the fact that AJAX now requires things, has operations, some which are, well, I would say, extremely high priority, like ordering. The user does a search. You want to get those out. User-instantiated actions are typically the highest priority. You want to react as fast as possible. Non-user actions, such as getting those images, you know what? They take another few seconds. I'm sure the user would rather get the results of what they've done. So we've prioritized everything so we control the order. And we apply that system to not only how we do user actions, but how we deploy our entire site. A very broad generalization is the more interactivity you have, the more code it requires, which will typically yield a slower site. So how do you build sites with lots and lots of components without quickly falling over under the weight of the scripts? Well, in the case, how do you build a live.com? And I'll admit, we have a lot of work to do on our perf, but how do you build it? How do you efficiently deploy those resources? First thing I want to do is explain how the browser deploys scripts. Most people don't realize this. If you have 20 scripts on your page, traditional script tags, referencing an external script, every time the browser hits one of those script tags, everything stops. Hard stop. Browser's loading that script, hum-de-dum-de-dum-de-dum, parsing it. Hits the end. Browser now continues merrily on its way until it's that next script tag. Everything stops. Scripts are universally single-threaded to the point where it serializes everything. So if you have 20 scripts on your page, you're stalling your page significantly. So what we've done is said, wait a minute. We're going to try to alleviate that constraint. We only load one script in Windows Live, or it's actually split into 3 for caching reasons, but it's basically one small piece of functionality in a Windows Live via the script tag. Every other script we load ourselves dynamically, and we can load scripts in parallel. Now, what does this mean? One, I'll just give you a real-world number. Take a 100K script, split it right down the middle, 50K each. We loaded through our loaded through our system where it could go in parallel. We saw a 12% perf gain, no change. Simply by freeing up those other connections, unblocking the browser to allow it to do its work. Now, with that approach, though, it implies that you build your code a certain way. Earlier, I made the statement about object-oriented code and everything else. Our code can load in any order. We're parallelizing it. So if you have 2 scripts that make up a component, they need to be able to be parsed by the system in any order. What that means is when they're being parsed, they can't call each other. But once I have the dependency graph, which we maintain, and I instantiate the object, now you know everything's there and you can call between them. So it basically changes you from writing inline scripts to writing encapsulated objects. It basically drives that. So patterns, prioritize. The other key point I want to make, and this one's kind of tied to all this, a general rule, and this is, again, another one of those little tips. If you have static content, never expire it. Mark expiration forever. If you change it, change the URL in your system. Now, we're architected to make this easy, so maybe it's not as simple as I'm going to make it out to be. But the benefit is you want to leverage that browser cache as much as possible. And I forgot my last point, so we'll continue. Oh, I remember. It wasn't on here. The other tip. Remember I made the statement about 2 connections per server. Well, one of the other things you could start doing is saying, well, you get 2 connections per domain. What are the resources that do not have to live on your domain? Images could come from anywhere. Great. Put them in a different subdomain. Scripts can come from anywhere. Put them in a different subdomain. Style sheets can come from anywhere. Put those in a 3rd subdomain. So now, between your AJAX calls that have to go directly back to your domain, the scripts, the CSS, and the other ones, you could get 8 connections running simultaneously. Now, obviously, this could be potentially more expensive on narrowband, but at this stage, I believe most of us can optimize, assuming a reasonable amount of connectivity. You'll gain significant advantages by finding ways to leverage as many connections across the many domains as possible. Cross-browser development. Here, this is an interesting challenge. I mean, first off, I'll start on the bottom and work up. The IE guys have already beat you guys up enough on this. Please eliminate your hacks. Not only because of the fact that they're getting fixed in IE7 and they're not needed, but more so, and I use this as a simple example, it makes your code unmaintainable. I know all the hacks in the book, at least I think I know them. I still look at CSS sheets that use them, and I can't make rhyme or reason about what the hell they were doing. I can't figure out why they were applying this hack, why they're using the greater than selector to get this thing out of opera and in IE and vice versa. It doesn't yield a very stable system. Instead, there are times where you got to do overrides for different browsers. The approach we're doing in Windows Live is classifying the HTML node. When we load our pages, either automatically from the server or on the client, we will automatically inject classifications on the HTML node. So we'll say HTML, this is obviously Mozilla version 1.5 on Windows. So now, if I find a rendering bug or a rendering issue in Mozilla, or let's say IE or any browser, I create a very simple selector. By default, my body's going to have a 10-pixel margin. For some reason, I decided in Mozilla, I want a 5-pixel margin. That is transparent and easy to anyone walk up to and say, why am I doing that over? Why did he come up with that override? Oh, in Mozilla, he needed to override it. I could go .mozilla, .m1, .d5, .windows. Mozilla in Windows version 1.5 override. It becomes a declarative way for you to quickly look and distinguish why people had to do things in a different way for a different browser. The other way we've done this, and there's many ways you could abstract browser differences. In Atlas and in Windows Live, we share a single approach, which is we built a compatibility layer. With this compatibility layer, we've basically provided the IE-isms into all the other browsers. And that's something that we found very useful. For example, mouse capturing. If you know anything about the HTML, mouse capturing is only supported in IE. It works in Firefox with our compat layer. We expose enter and leave events that IE has because they're easy to work with in the other browsers. The attach event, detach event. Rather than do the event object, rather than do in all our events, the little switch, is it the event on the window, is the event being passed in? If you're a web developer, you know what I'm talking about. Our event object is globally available. We made sure all this happens transparently. So when we write our code, we write it to one browser. We basically write our code one way, and it just runs universally. The remix experience. This is what I've been saying. One of the other challenges is how do you maintain consistency? This is a critical issue. How do you reflect your site's look and feel over third-party components? How do third-party components build CSS that does not impact you? I've illustrated some of that. Earlier, but the real challenge here is, and this is going to come down to prescriptive guidance. We're going to work in ways to make sure that in Windows Live, what we've done across all of Windows Live is we share the same class names across all our properties. We're going to enable ourselves to be universally themable. As we start exposing components that can be remixed, we will publish the approaches we're using and the CSS class names. Unfortunately, this is one of those tougher problems where if the site wants to infect inward, there has to be prescribed guidance. It's not an easy technological solution. Again, another question that we need to address, I don't have an answer for, is a simple one. As you remix experiences, what if in your site you chose a standard of yes, no buttons, and that component you remix was OK, cancel? How do you do that? How do you handle localization, where when components get dropped, how do you share market culture information? Atlas actually addresses some of the culture information and so on, but these are challenges that we need to work on as we move forward. Now here's the evil side of building these rich applications. When I say evil, these are the things that really, really bite us, which are back button and addressability. First, remember earlier I said I have an example where maybe we did wrong with AJAX. And you know what? I was on this team, so I'm not going to worry about the fact that I'm actually demoing what we did. But let me go find... well, my machine decided to turn itself off, so let me just go from here. I'm just going to go quickly to one of our spaces. This is actually my blog, so you can write down a URL. I write a lot. I haven't done it recently, but I write a lot about these type of development patterns. But you'll see this Read Comments button. I'm going to click Read Comments. All right, great. I see the comments. What the user expected. I'm done reading those comments. Okay. I'm going to go back up. What? I'm back in mail. You really think they wanted to go back to mail? No, they thought they were leaving comments going back to the entry page to spaces. That is the example of you got to be very careful how you break the traditional, that you might break the traditional web model. The people expect the web to work. Things that are navigations, even if you build them with AJAX, you should try to make sure you maintain some sort of semblance of that history stack. I'm not so as concerned about the forward button. Forward button is really more for us, is not used as prevalently, but breaking that back button causes your users lots and lots of pain. Unfortunately, thinking back to what I said in the beginning, the browser is not this really, doesn't provide a lot of these services you need, so there are creative solutions for doing the back button. Typically they involve using hidden iframes and tracking state. That's again a 30-minute talk just to walk through that, so I'm not going to walk through the code. But the key message here is when you build your AJAX-oriented interactions, decide what is a navigation, aka something like viewing comments, versus what is a verb. For example, the order it button. The order it button, I don't think people, or adding a stock quote, if it renders in place, hitting the back button, no, I don't think many users are going to really expect the true undo stack where it's going to actually remove it. But you're doing something that feels like a navigation, try to make it a navigation. URL addressability challenge. This is the other challenge with AJAX. As people are navigating through your site using AJAX and are drilling in through different contexts and so on, they reach a great state of your application, add it to their bookmarks, reload the page, and it started them over. Because the address bar cannot be updated in an easy way. Locallive.com addresses this. Again, I'm going to flip over. Come on. There we go. In locallive.com, they have the ever-discoverable permalink button, which everyone's going to find, which is going to give you a URL that'll get you back there. It works for the more technical savvy, but there's a challenge here on how to address this. Unfortunately, with Windows Live's recent update, the demo is going to show on Live is no longer necessary, but I'll explain what they used to do. In Windows Live, I search for HTML. They used to do history correctly, but if I hit the back button, I believe they do history correctly. Good, demo worked. When they hit the back button, you'll notice they took them back to the live entry page, not like in Spaces where they left the site. But that search box rendered overlaid on the page. The other thing I want to make clear is look at the URL. It got updated. We did not reload this page from scratch. We realized that, and you can update the hash. A hash is the pound sign, if you can't see what that thing I highlighted up there. You could change the hash of the URL without reloading the page from the server. So what we do in Windows Live is, as users typing things that we know they want to be able to have re-entrancy into, for example, they find a search they like and they want to email it, we update the hash. Then when that gets mailed to someone, when this page loads, the server doesn't see that hash, the client processes it. So that's all back to the client composition approach I said in the beginning. Accessibility. Here's another one of those really big problems of the web. It's very challenging. At the root, please build your websites using proper HTML semantics. The number one example I'll give, and we are guilty of this too, so I won't claim we've done it perfectly either. Things that are going to be clicked on should be hyperlinks. If you put onClick on a span tag or a div tag or any other tag, accessibility tools don't know about it. Now, if it's a button or any native form component, you're fine. But if it's text that needs to be clicked on, you really need to have a hyperlink on the page. If you're creating a list, don't use a bunch of nested divs, like a menu. Create a bunch of nested, unordered lists and then style them with CSS. Use the HTML semantics appropriately. The next challenge, well, what do you do about basic DHTML? I call these synchronous actions, like hide and show for contents on the client. One, make sure that the element that they're clicking on it hides and shows, again, is that hyperlink, is a clickable item. Make sure that the effect, the content you're about to show, is close in context to what they clicked on. So when they click on it, it expands in place so it gets read to the user right after it's clicked. Now the last one, this is the real challenging one. How do you handle asynchronous actions where you're updating the page on demand? Unfortunately, this one is a bit of a challenge. Here what we need to do is we update the context, and the way we have to tell an accessibility tool the page changed is we discovered we could navigate a hidden iframe. And then accessibility tools will say, oh, it must be a new page, and they'll reread the page to the user. Now, unfortunately, these are all kind of techniques to apply. I'm hoping we work with the IE guys, and in the industry, the browser will just get better at this. So I'm finally to the end, and I think I did pretty good on an hour-and-a-half presentation, cramming it in. But building web applications. To me, the big evolution here is that reconceptualize your application as a mashup. The whole thing I want everyone to think about is how do you engineer your site in a way that allows it to have longevity, stability, and robustness. Avoid and minimize breaking the web model. Use the network stack intelligently. Recognize the constraints of it. There's a lot of places to go learn more. I mentioned a bunch of talks earlier. Explore Microsoft Gadgets, the live clipboard. Download the latest Atlas CTP. Actually, you all should have it. It was handed out, I believe. Invest wisely. This is really the net nut of anything. Don't lose sight of your customer. Don't use the technology for technology's sake. Make sure you have the proper business justification to make these decisions. Make sure you understand if you're going to assume the network is reliable, make sure that's a conscious decision. Otherwise, it could come back to get you. And that brings me to the end. Thank you. And I have time for questions, and worst case, we can take questions to lunch, too. Yeah, is that mic on?
Yeah, there it is. Okay. Do you do much dynamic script tagging, and have you gotten it to work with Safari?
I'm glad that was asked. Actually, if people are still here and they want to understand cross-browser, it's a good question to hear the answer to. The question was dynamic scripts in Safari. We are getting a lot of feedback from people that Windows Live does not run in Safari, and people are yelling at us. And you know what? Whoa, my voice went up. The reality is, the way we deploy our scripts on demand and in parallel, the Safari browser exposes no events that lets you know when a script is actually loaded. They let you load a script dynamically, but we can't detect that it actually completed. We've been working with the Safari team. We've notified them, discussed with them. But right now, unfortunately, it is a pure technological limitation that we just have no way to basically enable the richness and the way we want to do our client composition in that browser. And I really hope it gets addressed soon because I'll admit, I even have a Mac on my desk. It works great in Firefox is the only answer I could give right now. Firefox and the Mac will work. The events are part of the standard. Firefox, Opera, and IE support them, and it works fine there. So, yeah, the answer is no, I haven't found a good one.
Yeah, I haven't figured it out.
I mean, the one trick is we can't use this. If you do want to just load a dynamic script, put a callback in line as the last line of code. So when Safari parses, it'll hit that callback line, and it could call back to you. That works if you own your scripts in-house. It doesn't work as a generalized solution. Questions?
Yes. One of the things we've found, we've been building AJAX applications for a while now, is JavaScript sometimes is more of an art than a science in terms of performance and stuff. And you guys have spent a lot of time in that world, certainly for the live properties and stuff. Is there any plans on doing any prescriptive guidance around how to write better JavaScript to perform better?
The question was how to write better JavaScript to perform better. The first thing I'm going to mention, what typically kills JavaScript performance is memory leaks in the browser. So the first thing I would argue is not even prescriptive guidance, which is examine yourself. Do people understand? Actually, I'll explain memory leaks in the browser. IE6, which is predominantly fixed in IE7, has a memory leak issue that basically causes lots of pain, especially if you use JavaScript closures, if you know what they are. If you create a circular reference between a DHTML DOM object and a JavaScript object. So let's say you go document.body equals a variable foo, and then on foo have a property that equals back to document body. Create this reference. You will leak memory unless you dereference that. So what typically is happening, we've seen on the web, and no one's perfect at this, but we're trying not to leak memory, is you go visit a website, and it leaks some memory. You visit another website, it leaks some more memory. The cumulative effect keeps slowing down the browser. The most important thing you could do, and this is one of the reasons we put in object lifecycle as a key constituent of how we build our stuff, we make sure all our objects always clean up after themselves, to the point where we pretend we don't have a garbage collector. We don't let the variables just go out of scope. We null them out explicitly, because we don't want to take a chance. Now, beyond that, some of the stuff I said about using JSON versus XML, the key thing I really look at is one, recognizing that the garbage collector isn't perfect, and the memory leaks. It's usually the memory leaks that burn most people. Beyond that, I would have to sit here doing my hour dev talk. But yes, I really hope, in part of at least our Windows Live Dev Center, and I know with the Atlas guys, we're going to want to publish lots of good guidance on what we've learned and how to help people.
Thanks.
Hi. Can you speak about your experiences using Atlas with SSL and a matchup with SSL and non-SSL sites? How would they work?
Mashups with SSL. That's an interesting challenge because typically the moment you want to consume SSL, you have to go SSL universally if your client's making the request. So beyond that, does Atlas do HTTPS bridging? What? You haven't tried it yet. One of the things that we're exploring in Windows Live is that if it's doing HTTPS bridging across the back end, so we can make an HTTP request to our server and then mash up via HTTPS. Now the problem there is there's a whole bunch of security implications. HTTPS and security is one of those interesting challenges. For example, I'll tell you right now, I rarely will use a component written by someone that wants my name and password. So how do we start doing remixable components? And that entire pattern is, I think, one of those next cusps that we're going to all start exploring. How do we securely integrate with partners in a safe way that protects our users? So unfortunately, no, I don't have a great answer. But one of the key technical challenges right now is that the browser, if it's an HTTP page, cannot request from an HTTPS server. So it's one of those, do you want to bite the bullet and go entirely HTTPS across the board?
Two questions. One, are you familiar with the Dojo toolkit? Because it provides a lot of solutions to things like the i.e. memory leaks and history issues and the backclick.
I'm somewhat familiar with the Dojo toolkit. And as I don't know if you were here I made a point in the beginning. Everything I express in this talk is probably universally applicable to a lot of the richer frameworks out there. The memory leak one, I haven't looked too deeply at Dojo, but one of our big things is all about the object lifecycle. We have a system where objects get created and destroyed very dynamically. I'm not sure if Dojo is still more oriented for garbage collecting at a page model or at a component level. I don't know.
Okay. The other question was, what about increasing the connection limit to the same domain?
Talk to the IE guys. I agree.
I did, and they said no because the RFC says no.
That is
kind
one
of a lame excuse because.
Yeah. I can't. I was on the IE team for many years. I agree with the introduction of broadband. You would think those limitations were more to protect the servers in the early days. And today, it'd be interesting if there was a way even to express that you want to enable. Like let the site decide. I could support more. I mean, there's lots of creative solutions, but the IE team would own resolving that. Any other questions?
What's the best way to test Atlas AJAX applications?
The way we are doing our testing, and maybe I'll even invite for the Atlas side, is due to the fact that we're building everything in a very componentized, modularized approach, we build a unit test around every one of our components. We don't, the traditional testing model of the web is you load up the page, you click, 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 click until it breaks. Well, that works somewhat well when it's mostly a server-driven approach where the page is rendered. Now that we're building these rich objects, we basically have our own unit framework, similar to the JS unit you could find out there. We've tweaked it a bit for our own use. So we build unit tests and make sure our components, all the interfaces and everything else run stably. Then we plug in the UI on top and make sure the glue between the UI and the actual interfaces works. And we test everything from the bottom up, the way we test traditional software. Now, the real challenge is the debugging environment is pretty horrendous in general. And that's kind of, to me, I can't give a good answer. I've been doing it long enough. I've kind of got the art. It's more, it's ingrained in me. What is being provided in Atlas on debugging? Use the mic. Jonathan, thanks.
So for Atlas, we use a similar technique to actually test our client-side code. We have a test framework, and we run full regression suites on there. Plus, we have a harness which we can test inside IE and inside Firefox, and we plug in other browsers. And then we also do load testing on the server, since we do quite a bit of service communication back through to the web server. In terms of debugging, we have started discussions with the script debugging team of how we can make that experience better.
I'll ask the question for everyone else. Are you going to provide those harnesses?
Obviously, as people build more applications for the web, I think it would be good for us to put some of those types of tools inside Visual Studio.
I have a question on the server performance. With the AJAX implementation, there will be more interaction between the client and more frequent interaction with the client and server. What's the impact on the server response-wise and the memory usage-wise?
Sorry.
With the AJAX, basically there will be more interaction with the client, the frequent interaction between the client and server more often than instead of one
Correct.
page.
Okay.
So what is the impact on the server performance-wise or load-wise?
Well, we run a mega-scale service, so we kind of covered that. But from the standpoint of, that's what I was addressing in the chattiness of AJAX interfaces. The key things that we're trying to explore is, one, short-term caching. So while we might take an extra request to load the page initially, if they're quickly flipping back and forth between pages, I'm not hitting my server over and over. The other key thing, which is the batching, which I know is in Atlas, is the idea that if your page is going to take 15 requests to the server, combine all those 15 requests, hit the server, let the server handle them all, combine the results in one return response, come back to the client, redistribute to minimize the chattiness. That's one of those trade-offs that basically needs to be decided, especially if you go server versus client compositing. A lot of times you might decide to save some connections, serve the initial page entirely from the server, overlay the behaviors, and then only via direct user interactions, go back to that server. So at that point, you actually will argue you will scale better, because if the user did something that required data, you would have had to go to the server anyway. So you could try to minimize the upfront impact of loading by putting maybe more in the page up front. It's really a balance. I don't claim there's one right way or one wrong way. It really depends on the needs and what your desire is with your application. Okay. Did that help?
Yeah.
Okay.
Thanks.
That sounds like a solution for a lot of applications, but just for fun last week, I was curious if I could create sort of an arcade-style multiplayer totally in AJAX, and I'm hammering the server at about 24 frames a second for each player. I can't really cache that. And I was wondering, I've been sort of exploring all of the headers and everything that IIS is returning, and there's all of this extra data. And I've been trying to find out, is there some way that maybe we could have a lean AJAX request? We don't need all of this header information that a normal HTML page is requesting. Is there another alternative?
There are explorations, not only on that side, but to provide better security and so on for these cross requests. I'm just going to stress, I've seen a lot of people starting to explore how to keep a persistent connection open at a client. Because so you don't have to pull 24 frames a second. Now, I won't claim this could scale to millions of people, but you can, there's some techniques out there we can maintain a two-way connection with the server so it can continue to stream to the client. One of the sites that I occasionally, I think there's a site, ajaxing.com. I saw some references to some documentation about that. There's a lot of people starting to play with it. I'm not convinced it will scale well, but it may help you at least with some of your explorations.
It's just a test. I want to see.
Yeah, so I would definitely go look at that. I mean, the interesting thing on that one is can we do something that will allow us to maintain these persistent connections in the same way? Go beat the IE guys up. That's what I would like it to. Looks like John has something to say.
I think Thomas Demo from the IS7 team has a talk tomorrow. So, and they've done a whole bunch of rework in terms of how IS is put together. And pretty much you can take out sort of most of the modules. So I would go to the talk and then go and actually ask Thomas those questions, and hopefully he will have some solution to that problem.
Thanks.
What is conceptually wrong with iframes, for example, when we are using mashups? Why do we need to dynamically assemble this page if we can use the iframes? They better isolate CSS, they better isolate scripting and all that
All right.
stuff.
The question was, what is wrong with using iframes? There's a few things. One, if I really did want to build a themable site, the themes won't infect properly into the iframe. Two, iframes consume a fair amount of memory. Me loading a component directly in line at a page, let's say I put 10 components on a page without an iframe. I just saved myself on order of probably 20 megabytes of memory, which is very significant. The other thing is iframes actually do have one other benefit. We do use them in gadgets. We use iframes to create what we call process isolation. If I want to load something that is untrusted, I will load it from another domain so it can't communicate easily back with the root page, which is actually, I could argue, another disadvantage to iframes, but it's solvable. It's hard to do the cross-frame communication in a sane way, especially if you have a shared framework. You don't want to have to load that framework in every single frame to get core services, because then you're bloating your memory again. So you're going to want to create all this interconnectivity of the contents of the frame to the root and so on. Really what we want is what I would call a lightweight iframe, which if you're familiar with the term transclusion, the ability to basically say I want to transclude some content into my page without instantiating a whole nother instance of the browser. That's kind of what we're emulating now in our infrastructure, which is the ability to include things directly into a web page. So does that help with the answer? A lot of this really comes down to performance. Any other questions? And I'm getting music.